Mic check. Mic check. Can you hear it on the computer? Hello? Hello? Okay.
Yeah, sure. Mic check. 1, 2. Mic check. Mic check. 1, 2.
Oh, sorry, it was disabled. It was disabled. There is a delay. The delay on stream is like about. Yeah. Okay. Nice.
All right, nice.
Yeah. See? Oh, there. We can even do 2 cameras on the live stream.
That's pretty cool.
That's pretty cool. Right. All right. Well said. Ooh.
Nice.
Okay.
Says, can I join you?
That was excellent. Ooh, actually, that reminds me. Oh gosh, I'm gonna forget how it goes though. I'm gonna embarrass myself and try to tell this joke without thinking about it first. Oh man. Okay, so I think it goes like this. A man walks into a bar. He orders 1.227 root beer floats. And the bartender says, "Ooh, that's a lot. Better make it a double." Get it? Float versus double. Yeah, sorry. It's not really a Ruby joke. Oh, but Charles gets that one. That's a Java joke, right? Yeah.
Okay, you want to kick us off? Or?
I do want to say that the food today is maybe setting a new bar for like high quality, because like, not to disparage our other hosts, but this is like, I don't know, next level food today. I'm really impressed. So let's give it up for our hosts, Chime. Thank you, Chime. Awesome.
Shout out to the workplace and culinary teams here at Chime. They do a lot of good stuff and
Nice.
give us all kinds of good food.
Sweet. That's awesome. Thank you.
Yeah.
We did discover, oh, it works. Hey, the live stream is working.
We are live on YouTube, folks.
Sick. Awesome. All right. Do I need to connect something?
I think we're going to make a quick announcement. For
You just this part.
Yeah.
Got it.
Well, welcome everybody. We're so excited to host our second SF Ruby meetup here at Chime. I'm so glad to see all these lovely Rubyists here. And yeah, we got a bunch of great speakers lined up. Help yourselves to any of the food and drink that's over there. We have a lot, and would hate to see any of it go to waste. Yeah, without spending too much time up here, I just wanted to say, Chime, we are hiring, and we have our recruiter Lindsay here, who has just a couple words to share about what we're sort of looking for.
Hey everyone. I think everybody up here to speak a little louder so everybody can hear in the back. I am representing Chime on the recruiting side, and we have multiple positions across all orgs open. I'll be here till about 7-ish, like just hanging out over there. So if you want to come mingle, connect, super happy to. Yeah. Also, restrooms. I've had a couple people ask me where restrooms are. It's kind of hard to find. Where you entered into the building and got off the elevator, you're gonna go that same way, but just keep going to the right down the hall, and then you'll find restrooms. Cool.
Awesome. Thank you, Lindsay. Okay, with that, I think we have a couple announcements from Arena, our gracious host, and then we'll get started with the talks.
Yeah. Right. First of all, super stoked to see everybody here. I'm just gonna turn the volume up a little bit. And yeah, great seeing you all. Please come join us. And there's one big announcement that I wanted to make. I wonder how many of you have heard of it. I just started sharing a few days ago about the San Francisco Ruby Conference. Thank you. So this is happening thanks to all of you being so active in the community, joining the meetups, companies like Chime hosting the meetups, hosting us, and all of you bringing your ideas, speaking, submitting CFP. This is also being just a very active, very good group to discuss those ideas and to really ask great questions, right? I think it's super important. So I just want to share quickly what we came up with. So this is sfruby.com. So this is the conference website. It's live. And there's one more announcement. Jesus. You know what? I'm going to live code. Just bear with me. This is so, how are you guys doing it? No. I'm fine. I mean, right now I cannot open VS Code for some reason. Sorry, it's some random website. Should be here. To be honest, I'm pushing to main right now. just a sec. Never do it yourself. Never. I usually local changes. Give me a second. Git push. We didn't git push. We did. Let's see. You know what I'm doing right now? I'm actually announcing the call for speakers. Yay. Okay, I'll show you this in a sec. So basically, the San Francisco Ruby conference is going to be focused on two main topics. This is the new tooling, new open source, including AI for Ruby, that is built for ambitious companies, for ambitious features, for all the new stuff that we want to build. And the second topic is scaling Ruby, because we have amazing known Ruby success stories here in San Francisco. So we already have amazing first speakers confirmed: Obi, Vladimir, Carmine, Marco. We built on the success of this meetup. We have the first sponsors, and the very first sponsor who supported us without anything being confirmed yet was Chime. And Chime, Bolt.new, and Gusto are our first three sponsors. All three companies are committed to Rails. I want you us all to appreciate that. They're supporting a conference that never existed. Nobody knows if we can pull it off, but of course we can. I mean, seriously. So the conference is organized by Evil Martians. That's us. Oh, there it is. Woo. So the call for speakers is live. And you can submit the proposal till July 15th, but submit it early. Don't wait for July 14th. I've been there. Don't do it. And yeah, this is the call for speakers. And we also have call for Ruby startups. Look at this. I think it's pretty cool. So we're going to have Ruby startup demos at the conference, just because we are in San Francisco. And let's bring them over. If you are, I know a bunch of you work for startups, come demo your product. Come get us inspired with what you're building. Let's do it. And yep, that was my update. So I'll be waiting for your speaker proposals, all of you. You cannot get away from that, And yeah, and then we'll launch the early bird ticket sales soon. There's a countdown on the website. Take a look. We are looking for more sponsors. Of course, we are trying to make this conference very affordable. Our early bird tickets are going to be $300 for a 2-day conference. So we're trying to keep it very affordable so our friends can come from different other places. And, so yeah, looking for sponsors as well. All details are on the website. Please help us share news about this conference. This is going to be super important to try and bring many more people over. Try to bring many more people that build with Ruby, that like Ruby, but are less engaged. Let's bring them over here. Let's bring them for the conference. Let's bring them for the meetup. We also have a hackathon, but I think Camille is going to talk about it separately. So there's a lot going on. So that's all thanks to you. And this is my huge gratitude to all of you for being so active and such an amazing community here. Thank you.
Okay, do you have the Zoom link? We can send it on Slack. Oh, I don't know.
If anybody is thinking about Wi-Fi, it's Chime Guest, and the password is visiting small letters, all small letters, visiting. Chime Guest visiting. Yeah. Slack. No, oh, it's me. Sorry. Where is it?
Awesome. Thank you, Irina. I'd like also to give just a huge round of applause to Irina for not only organizing this meetup and getting like meetups back in SF. A couple years that the SF Ruby meetup didn't really exist, wasn't doing anything. She revived it. And then we have the conference coming up and the hackathon, most of which is really due to her organization. So big round of applause to Irina for managing all of this. Okay, I just have a few intro slides here, not super big deal. There we go. Okay, so yeah, just this is our. Well, I guess I have this slide also. Sorry, 1 second. Where is my mouse? It's disappeared. That's really frustrating. There we go. Welcome. I like Jim Carrey. So yeah, this is our schedule for today. We have a couple of talks. We have Charles Nutter from, I think, Minneapolis, right? Flew in and is going to speak to us today, our keynote about optimizing your Ruby world with JRuby. Charles is kind of the JRuby guy. We'll have a talk from Clickhouse, the break, open mic, systematic LLM evaluation with Kieran, and then active agent with Justin. Open mic, just in case you haven't come to one of our meetups before, is an opportunity for you to stand up in front of everybody here for a minute or so and talk about whatever you'd like to talk about, hopefully Ruby related. So yeah, that's our schedule. We also have a Slack channel if you are curious about connecting more with people that you meet here. A lot of us are on Slack. So scan that QR code, that'll take you right there and sign up for our Slack workspace. And a big thanks to Gusto for sponsoring Charles coming today. They've been really kind, giving us money to do things like fly speakers out, and also lots of other things we're planning on doing with that. So big thanks to Gusto. And I think sort of without further ado, I will ask Charles to come up and connect, and we'll get going with the first talk. Did you read us? Yes, let's see. Are you on the Wi-Fi?
No.
As we're connecting, I'll just mention that Charles is in so many Slack workspaces. It's like having a bunch of Chrome tabs, although there might even be more than the average person has Chrome tabs.
Yeah.
It's amazing. I've never seen that before. It's amazing.
Yeah, that's no problem. Okay. Where is screen share? Right in the, oh, there it is. In the middle. Okay. Oh, yeah, sure. Looks right.
All right, here we go. Take it away, Charles.
All right, great. Thank you. All right. Great to be back in San Francisco. It's been a while. I know some of you. Thank you. I know some of you, and I'm excited to see folks I haven't seen in years. I'm happy to get to know everyone else. And let's get right to it. I'm going to talk a little bit about JRuby and how I believe that it kind of helps optimize a lot of different aspects of your Ruby world, not just performance. There's many different ways that we need to improve our Ruby world here. There's my basic information. Feel free to contact me on pretty much any service. I'm on all of them. Email's fine too. I've been working on JRuby for over 20 years now, which is shocking to me as well. But it seems like it's still being used and still people are interested in it. And I think as long as Ruby is important, JRuby will be important too. I've been a full-time JVM language advocate for many years. I believe that JVM is a really excellent platform for dynamic languages, for various languages, and especially with a lot of the work that's been coming in the last year or two, incredible improvements for what the JVM can offer to a language like Ruby. Up until recently, I was at Red Hat for about 12 years. About a year ago, we decided to part ways. They had different priorities and I had other priorities. So now my company is funding JRuby development and working with customers and users of JRuby to do support contracts, direct development help, and all of that. So I'll talk a little bit more about that later. Basically, it's the JRuby company now, and we're keeping the project going. All right, so let's get to JRuby here. How many folks have used JRuby at some point? Okay, there's a few folks. Good. How many people have heard of JRuby before or seen a talk on it? Okay, so you know a little bit of the details. Of course, this is Ruby on the Java virtual machine. It's JRuby. I didn't choose the name. I would have chosen, Cool Ruby or Fast Ruby or something way back when. But JRuby is what it is. We really focus on making it a Ruby implementation first. We want the ecosystem to work. We want all of the same libraries you use to work, the same command line workflow. Trying to fit JRuby as much as possible as a drop-in replacement for the standard CRuby MRI implementation. So we want Ruby code to just work. There are issues with supporting the extension API. Any new implementation really can't support the standard C extension API very well. So we have our own API for that. We don't support forking because the JVM doesn't support forking, but with threads, we don't need that. And with real parallel threads, usually you can do everything in one process anyway. So thousands of production users over the years, 18 years at least of real world use. I still hear from people who have apps in production that they haven't touched for 15 years and they still work great. So what is it important? What's important about optimizing in the Ruby world? What are the things that we need to do? Well, first of all, I think usability is something that we work heavily on in JRuby. Like I say, we want it to be a Ruby implementation first. So it needs to run the things that you expect it to. Ideally, startup and warm-up time don't have some of the downsides of the JVM, and we work around that in various ways. We try to take advantage of runtime features on the JVM. We try to bring all the features of the garbage collector in JIT to Ruby applications for optimization. We try to bring all of the tooling, monitoring tools, profiling, and so on. We have lots of platforms for the JVM. We can bring Ruby to mobile environments. We can run run Ruby at very large scale on server environments. There are desktop applications. There are point of sale terminals that run on JRuby with Android. All sorts of different areas that Ruby can go because of JRuby. And then, of course, we also work on optimizing performance, optimizing straight line performance, running code fast, optimizing scaling and parallelism so we can do more with one process, take advantage of more resources. And in general, we've found that there's lots of different ways people use JRuby, lots of different types of applications that people can write in Ruby and take advantage of what we've got. So the basics of getting started, of course, you can go to jruby.org and you find all the information there. But it's really a pretty simple two-step process. You install a Java runtime, and the current version of JRuby 10 requires Java 21 or higher, so fairly recent version of Java. We recommend you always just use whatever the latest is, whatever you're comfortable with at that level, because every time a new Java comes out, JRuby ends up running faster. You want to upgrade, you'll get better performance generally. And then install JRuby. The typical Ruby installers all know about the JRuby releases, so those will all work fine. Most Linux distributions have packages for it. There's Docker images out there. We've got a Windows installer. You can even just download the tarball, unpack it, and run it. There's nothing to build because it just runs on the JVM. So it's really easy to get it up and going. All you need is some JDK installed. Here's an example of running JRuby with Ruby install. We pull it written with Ruby install. It goes and fetches our most recent release, JRuby, and then we've got JRuby up and running. That's really all there is to it. You just need Java and an installer, and it's going. There is an IRB session with JRuby. Of course, the current version of JRuby now supports Ruby 3.4, so we're very excited to be caught up on compatibility there. And then a little bit of example of calling into JVM libraries. So here is the Java Lang runtime class that ships with the JDK, provides a little bit of information about the platform that the JVM is running on, but you can load it up into a Ruby session and call any of the functions. And this works across the entire library of Java features out there. So I mentioned the Ruby compatibility. We've jumped to Ruby 3.4. This was a heavy amount of work over the past year and a half or so, but we've jumped to 3.4. The vast majority of core library and language specs that are out there, including the CRuby tests, are passing on JRuby 10. The 2% that we don't pass ends up being a lot of weird edge casey features, weird parsing features that people don't use, certain pack directives that we haven't implemented. Generally, most people won't run into those, but we're constantly improving this level. Am I too loud? Okay. The standard library, we share all of the pure Ruby parts. I mentioned we don't support the C extension API that CRuby does, but all of the pure Ruby standard library is exactly the same in JRuby. It's installed as gems and uses the default gem stuff. That all works the same. The C libraries that we do need, we have JVM versions or Java versions, or sometimes we just wrap a Java library with Ruby code. We still are supporting our previous version of JRuby 9.4, which runs Ruby 3.1 compatibility, and this will probably be maintained for at least another year, and depending if there's customers out there that need it, we can keep that going longer. So I've been talking about all these JVM libraries that are available. The JVM has a whole new world, a whole new ecosystem of stuff that you can take advantage of. Tens of thousands, probably hundreds of thousands of libraries out there for anything you want to do, graphics or graphic user interfaces, new document formats, all of the stuff that's out there that we want to work with. There's probably a couple dozen libraries and maybe even 2 or 3 good ones that you can use directly from JRuby. It's truly like one of the largest collections of libraries in the development world, and it's all been designed around the JVM's capabilities, parallelism, runs well and scales well, and heavily used in production. And this is all available for JRuby. You can just pull these libraries down and start calling them as if they're Ruby libraries. So looking at some of the areas I'm talking about here. So this is a view of Maven Central and a list of all the different libraries that are out there. So this is a search for PDF libraries. So we have 1,139 different PDF related libraries that you can choose from. And there's at least a dozen really good PDF manipulating and processing libraries out there. How about LLMs? Everyone's doing AI, right? So how many LLM libraries? Almost 800 different libraries that have something to do with working with LLMs or calling out to AI services. Let's look for that on Ruby Central or on rubygems.org. It's getting there, 75, but about 10 times more libraries already exist in the Java world for working with LLMs. This kind of applies to pretty much anything that you're going to want to do. There's going to be a lot more options and a lot of libraries that are already out there and being used in production. So an example I want to run through here. This is a QR code for a blog post I did recently that walks through doing some charting, a charting library using JFreeChart, calling it from Ruby code. I won't expect you to follow all of the code here, but I'm going to show a quick demonstration of how this works in a few slides. So I mentioned you can pull down any of these libraries that exist on Maven. The way we do that in JRuby is with a jar file that sits in your project, similar to a gem file. You list your JVM, your Java dependencies. You run the lock jars command. It will fetch them down and use Maven to do it, so it fits into a standard Maven ecosystem. And then all you have to do is load the libraries into your Ruby session, and you've got them available. So we pull down our JFreeChart libraries here, and then we can just start calling it. A number of the standard Java packages you can just call directly. So here we do our two different ways of importing Java classes. First of all, color, rectangle, and buffered image, just assigning a shorter constant name to the Java package and class. Or we have a Java import that essentially does the same thing if you want it to be more explicit. So we import a bunch of classes from the JFreeChart library. Then we're going to read in a JSON file, create a standard category data set for this 3D chart we're creating, and then just fill it in with all of the data from the JSON file. The JSON library here is the same one that you use in regular Ruby applications, but of course everything else is using JFreeChart. So we call into the chart 3D factory. We are in the Java world, so of course we use a factory to do everything. Create a bar chart with a title, a subheading, some additional information columns here. Set up some basic structure for it, the shape, the color of the boxes, whether we're going to have a legend and where it goes. Do a few more tweaks for how we want to render the data in our chart. So we want the grid lines to be black. We put a little label generator here that actually hides some additional text that we don't want in our output. We just want a nice, simple 3D bar graph. And then we use standard JVM utilities to take that chart, render it into a in-memory buffer, and then that buffer goes out into a PNG file. And that's all that's required to render this. So now we've actually pulled in this library and only using pure Ruby code have managed to populate the data using JSON library from Ruby, render it out to a PNG file, and didn't have to write any additional code. No native code required for this, no C extensions, nothing needed to be installed on the system other than what we pulled in from our jar file. Now, of course, we also have other ways that we can render this. One really nice thing about JFreeChart is that it also supports rendering to other formats. So here are two examples. We can also take exactly the same code up to the point we did the PDF and render it out as SVG, as scalable vector graphics. We can render it out as a PDF without changing any of the other code because it's built into this library and it knows that when you're writing out to this in-memory buffer, how to turn that into an SVG or a PDF. And there's a couple other formats that are out there too. So it's really that easy to pull in all these libraries and start using them from Ruby. Now, of course, there's a lot of GUI libraries on the JVM that are available. A couple that I wanted to run through here. So Swing, I won't have a direct example, but this is the basic GUI library that's built into the JDK. You can use Ruby to call into Swing components, build a desktop application, and ship it anywhere that you can install Java without changing any code. No requirement for installing any native libraries. It'll run the same and work everywhere. There's another one called SWT from the Eclipse project. This is similar structure to Swing, but it uses all of the native widgets. So if the Swing widgets look a little unusual across platforms and you want things to look like Windows on Windows or look like Mac on Mac, you can use SWT. And there's also a newer one called JavaFX, which is more of a scene-based layout of your graphical interface, similar to old Flash applications that you used to build using drawing widgets, drawing buttons, and so on. So there's a couple libraries out there in the Ruby world that actually wrap some of these libraries. The first one, Shoes, goes way back to Why the Lucky Stiff. Who remembers Why the Lucky Stiff? Yeah, there's a few. You can look it up. Shoes 4 is the latest iteration of a library he wrote to make it easy for new Ruby developers to build simple graphical interfaces. And Shoes 4, in order to be able to work on more platforms, they wrapped Java GUI APIs, Swing in this case, so that you could just use it on any JVM that runs running with JRuby. Glimmer is a much more modern and practical API. It's a very nice graphical user interface DSL, so that you can build with a very nice structured API, a builder sort of flow to it, but target multiple backends. The most mature backend has been the SWT one for JRuby. And you can build applications like this Tetris app. There are people with commercial desktop clients for different applications, all built in Glimmer and all running on JRuby across platforms. So definitely worth checking out if you want to do any graphical user interface work. We also do have a wrapper around JavaFX called JRubyFX that allows you to use the JavaFX scene API, but entirely with a Ruby builder structure to it. So our code here, we have our stage that we set, we lay out our scene, we have a rectangle, we have a timeline in it, we do some animations, all part of JavaFX, but wired into Ruby so it looks nice and fits into a Ruby world. We've also been updating a library we have called Rubato, which allows you to build Android applications completely in Ruby. This has been used, for example, for point-of-sale devices, for control terminals, the refueling terminals for the airplanes at the Oslo International Airport were for almost a decade running Rubato as the client application. It works very well. We're updating it now for the latest versions of JRuby, and we're actually getting issues fixed in Android as we do some of these updates because we kind of push the edges of it. But somebody in the community is currently working on updating this and making it work with his game framework that he's written for Ruby, which also works on JRuby just fine. Here's a little demo of Rubato IRB. It might be a little small, but you can kind of see what's going on. This is an application built in Rubato that basically just loads up IRB and lets you run it on your phone and type in commands. And this is a full JRuby environment here. You can type in your code. It has a minimal editor. It has some example scripts, but very easy to just start playing around with Ruby on your phone. Or if you're out and about and someone asks you a Ruby question, you can just run it and try it. Okay. So I talked a lot about these JVM features that we've got, things that we're really excited to bring to the Ruby world. Let's get into that a little bit. So probably the biggest one, and more recently this has been less of a concern in the C Ruby world, but still has some issues, garbage collection. The JVM has legendary garbage collectors, engineers that have worked on these things for decades, hundreds, thousands of man-years of work in these garbage collectors. So much so that we generally say if you're running an application on JRuby, garbage collection will never be your problem. You will barely notice. Many of these that are made to be pauseless, They will never have a pause in a production application. They can be tuned for incredibly large working sets up into terabytes of memory if necessary. You can work with a huge application and never have to worry about garbage collection on JRuby. Multiple options come with the standard OpenJDK. There are other GCs out there that are available. Usually the standard will be the G1, which is it's garbage first collector. So it's trying to collect only the garbage, and that's how it optimizes some of the process and avoids the pauses that you get out of other systems. ZGC has a similar architecture, Shenandoah as well, but lots of choices, and really any problem you want to throw at it, it's going to be able to scale really well. So the JVM also has some legendary JIT compilers built into it. The hotspot JIT is the most widely known, the most widely deployed. It's evolved since the late 90s, early 2000s. There are basically two different tiers, a fast JIT called the client compiler, the C1, and then an optimizing compiler that runs your code, profiles types, profiles methods, and then does a lot more inlining and optimization. Both of these will run typically if you just start up JRuby, and we get the full benefit of the JVM's JIT with all of the Ruby code. In fact, JRuby was really the first native JIT compiler for Ruby in about 2007 or 8, when I simply wrote a compiler that turned Ruby code into JVM bytecode and let the JVM take it from there. A newer JIT that's been very exciting lately is the Graal JIT. Does more aggressive optimizations, and I have an example of that later. And then there are other JVMs from other companies. IBM's JDK has a JIT that can save its compiled code offline between runs, has a JIT server that can share the load and compile for multiple servers at once. Lots of cool stuff there. And then, of course, there's lots of amazing tools that we have on the JVM. Two that I want to talk about. This is kind of three things here, but it's two basically. Visual VM is a standard console that ships with the JVM. It comes free with it. Lets you do some basic monitoring. You can see the CPU use of the process. You can monitor the GC. Flight Recorder is built into the JVM as a low profile or a low overhead profiler. You can actually turn this on in a production setting, only have about a 1% performance hit to your application, and gather method profiling information, object allocations, see what all your threads are doing, see if you're blocking on locks, all of the information available with very little overhead to your app. Flight Recorder outputs a data file that is readable by JDK Mission Control. That's the GUI that you would use to read that and analyze it and see where problems are in your app. So this is sort of a live view of Visual VM. On the left here is one of the standard tabs that you get, monitoring CPU usage, monitoring the actual usage of the JVM heap. If you see that continue to trend up, obviously you've got some sort of leak or you're using up too much memory. And then down at the bottom, some more internal details, how many classes are running, how many classes have been loaded onto the JVM, and how many threads are running. You'll notice that the JVM typically has 10 to 15 threads running just when it starts, because the garbage collector will use all your cores. The JITs will use your cores. It tries to spread this load out as much as possible across all of your CPU. On the right is my favorite plugin for Visual VM called Visual GC. This is actually a live view of the different heap areas on, I believe this was the parallel garbage collector. And you can see objects are being allocated. This is running a red-black tree benchmark. Objects are being allocated. The heap fills up a little bit. Some of the objects get promoted to another level. Some of the objects get collected. And you can watch over time to see how memory is being used and whether you're using too much or whether you're overloading the GC with certain amounts of objects. Here's a couple of views of mission control. Again, this is from the red-black tree benchmark. We can see that there are things like JRuby's Ruby fix num object, which represents 64-bit integers. We can see some of our internal structures. iRuby object is what all Ruby objects are for us. We can see some Java objects, but then up at the top, we can actually see there's a Ruby object. This is the node class from the red-black benchmark being profiled right alongside other JVM objects. So you can see where allocations are happening, how many objects are being allocated, and figure out where the hotspots in your app are. If we take a deeper look at this output here, let's see if we got... so here we go. Now we can actually look at method profiling as well. So this is a standard JVM method profiling tool in Java Mission Control, but I'm filtering by the red-black methods that we see. And we can see that the insert method is probably the heaviest here. Then there's max and min because it's doing various walks and testing of this red-black tree. But you can look into your application and see what the hotspots are alongside JVM libraries you might be using, alongside JRuby itself. Anywhere that there's a problem in the application, you can see it in this tool. So we've done our profiling. We want to work on performance. We're trying to optimize. What does JRuby offer for Ruby developers in that area? So first of all, scaling applications. This is kind of the classic problem on CRuby. We've got all sorts of different servers that will spin up forks because we can't do concurrent requests, can't do concurrent threads. So we got to spin up all these worker processes. Every time you spin up one of these worker processes, no matter how much memory you're able to share across them, you're still making another JIT and you're making another GC. Those JITs and GCs multiply that overhead by however many processes you've got running, however many workers, and waste time. What we really want is one JIT running for your whole application, one GC running that handles all of the data in your app. Otherwise, you're wasting resources. And that's what we get with JRuby running on the JVM. You can use a multi-threaded single process to run your entire site. 100 concurrent users, 1,000 concurrent users, whatever it is, you can scale it all up in one process. You will have a single JVM garbage collector that handles all of the overhead of cleaning up memory, and you will have one JIT that optimizes as you go, so you don't have to have multiple copies of all of that JIT code all over the place. So let's take a look at this in a practical example, a little baseline, just scaffolded blog application. I just start this up. This is running on Postgres, and then run it with Siege and just see how many requests we can crank through this thing. So this is, to be fully honest about, there is a bit of warm-up time with the JVM. The JIT has to kick in, the JRuby JIT and optimizations have to kick in. But after a few iterations of this benchmark, JRuby is able to exceed CRuby even with YJIT. These versions are a little bit old, but at the same time, CRuby's YJIT has gotten faster, JRuby's YJIT has gotten faster. The curve's about the same still. So what are we talking about here? This is just doing a simple benchmark. Straight line, one request at a time, not doing any parallelism. JRuby's still running more requests per second through this application than CRuby would, even with YJIT. So now the dirty secret though here is if we want to scale this up to multiple users, multiple concurrent requests, we're going to have to spin up multiple processes. JRuby, if you don't tune it, it's going to use a whole bunch of memory. It'll use, like on my system that had 16 gig, it tries to use about a quarter of that. But you can tell it to use only a 300 megabyte heap and choke that process size down. And this is actually a little smaller on more recent JVMs that have shrunk some of the non-heap data. And this is all you're going to need. Additional users don't require much more memory. You can run 100 concurrent users through this with no problems, never have to spin up another process. On the CRuby side, it starts out nice and small, but then you've got 10 users, 100 users, 1,000 users. You need to load more worker processes, handle all of those. They're all going to have their own working set, their own GCs, and eventually it crosses a line where JRuby uses quite a bit less memory. So this is an example that I ran with this same application, starting on the left with just one user concurrent, one worker with one thread on the CRuby side. JRuby doesn't win this, and we never expect that we're going to win this. The JVM is a bigger runtime. It's got a lot more, it uses a lot more space to make sure GC is efficient, so we don't come out as a win here. Crank it up to 16 users, we start to get closer. And here I'm being fairly generous with this and saying that we might only need 8 processes to really handle 16 concurrent users on CRuby. We continue to ramp that curve up, though. JRuby barely increases, and now we're trying to do 160 concurrent requests on CRuby. We're talking many gigabytes of memory just to get that running in parallel and get the latency down for those users. All right, so more specific optimizations I want to talk about. Now, I've mentioned startup and warm up and trying to make the most usable Ruby we can on the JVM. Those first impressions are important. The number one complaint everyone always has about JRuby has been startup time. I'm happy to say that there's work now being done on the JVM side that's really helping to solve some of this. Let's just jump right into that. So this is a little walkthrough of the JRuby compiler pipeline, how we actually turn Ruby code into optimized native code. On the left, we've got our Ruby code that comes in. We parse that and compile it into our own internal Ruby instructions. And then we'll actually interpret those instructions for a little while, similar to the CRuby interpreter, the YARV interpreter. Eventually, though, one of those methods will get hot enough that we decide this needs more optimization. Then we run in the background a JIT process that turns that code into JVM bytecode. And then the JVM actually repeats this same process. It will interpret the bytecode for a little while, profile that code, do a simple optimization, profile it some more, and eventually we get down to ideally the most optimized native code that we can. Now this process takes a while. There's various ways that we can shorten that cycle, but we want the profiling data to get the best performance. We don't want to compile everything because that would be counterproductive. So it takes a bit for us to get up and going. There are now some projects that are helping to solve some of these problems. Three that I'm going to talk about here. The first called Application Class Data Store, AppCDS. This basically allows us to pre-cache a whole bunch of metadata that JRuby sets up on boot so that we can jump right in to the first line of booted code and start executing more quickly. There's now work being done on actually caching some of that native code as well. So we can jump further into the process, save some of that basic JIT code off to disk and start running with fast code right away. And then a very unusual approach to this, the coordinated restore at checkpoint, the unfortunately named Project Crack, actually allows you to run your application to a particular point, save the entire process to disk, and then when you start up again, it continues from that point. Doesn't do any of the boot process up to that. And we've included some support for Crack in JRuby. There's a blog post on that I can point you to if you're interested. So what are we talking about for numbers here? CRuby, optimized for startup for a long time. And in fact, one of the reasons that it took so long for us to get JIT into CRuby was because Mots was very sensitive to damaging the startup time at all. He knows that there's a workflow that people use at the command line. He knows that there's small utilities people run. Worked for years to try and reduce this startup time as much as possible. And it's a very low bar for us to try and meet. There's JRuby without any tweaks. This is JRuby 9.4 before we did some of the optimizations in JRuby 10. Significantly slower just for a simple hello world. And of course, this is what people would complain about. So one of the things we do is we added a dev flag, --dev, that basically turns off some of our optimizations, turns off some of the JVM optimizations, and tries to just get to kind of a middle ground as fast as possible. And that's cut a good chunk off of our startup. The next one here, let me move this. Yes, so this is JRuby 10. Now this is JRuby 10 without the dev flag. Just improvements that we've done in JRuby itself to improve performance and startup time. JRuby with the --dev flag. Again, getting a little bit better. Now using the AOT cache support that's coming along and should be shipping in a JVM in the next couple of years. Down 2.7 seconds. And then, of course, if you can actually save the entire process and jump right back in, then we start actually getting competitive with CRuby startup time. Now we've skipped the entire process of booting up JRuby. We can even feed it code to optimize and pre-profile, and that solves a lot of the problems of starting up. This does have some specific requirements, like it has to run on Linux. You can only start up one copy of that process at a time. But if you're trying to do some quick applications, quick commands, this may be a way that we can go. So now the exciting part, the part I love working on, actually optimizing straight line performance in JRuby. So we heavily depend on the JVM for optimization. I mentioned these world-class JIT compilers. Of course, we got the garbage collectors that help too. The JVM's JIT is actually a design similar to what JRuby's JIT's working towards. The new JIT that was announced at RubyKaigi, ZJIT, is similar in structure, but of course we've got 30 years of work on the JVM JIT and thousands and thousands of man years on that too. We also have an IR built into JRuby that again is sort of similar to the way ZJIT does, so that we can do some of our own internal optimizations and try to feed the best possible code to the JVM so it can do the rest of it for us. So let's look at that red-black tree benchmark I showed you some profiles of earlier. Here's JRuby 3.4, 15.1 iterations per second, which is respectable for this bench. YJIT doing a great job, and we're super excited to see this kind of improvement in YJIT. There's a lot of work on optimizing. They're looking at some of the sort of patterns that are in this code. Now, JRuby 10, before I did any of these other optimizations that you see, is still faster than JRuby's latest YJIT, and I've got a bunch more work that's coming in the upcoming releases of JRuby 10. So, one of these examples. So this one was actually also brought up at RubyKaigi. JRuby is adding a new instruction to optimize the class new, basically how you instantiate any Ruby object from Ruby code. The way that it worked previous to this, you have to call out to C code. The C code allocates the object. It dynamically dispatches back to initialize, and that logic has its own overhead, but it also gets in the way of the new JIT work. It gets in the way of optimizing through that code. You can't inline the C code that's already compiled into the Ruby runtime, so it's a hard barrier for optimization. JRuby actually implemented this many years ago. We just sort of teach the JVM how to do allocate and initialize, how to cache the inline, or cache the initialize so that it will inline and optimize along with all the other code. And all of this works at the JVM level and optimizes down to native code. So let's take a look at a real simple example, just object.new. How fast can we construct new objects? So this is Ruby 3.4 with YJIT, 10.3 million allocations per second. This new optimization is a good 30% improvement. So clearly this is helping YJIT actually optimize through the object allocation and crank out those objects more quickly. And then there's JRuby 10. So it actually helps to go to a logarithmic scale here, but 217 million allocations per second happening here compared, so not quite 20 times as many objects per second. This is because of the way the JVM handles the heap. We can allocate objects quickly and throw them away quickly. They don't get in the way of the GC. The JVM JIT will optimize all the way down to that memory allocation, inline all of the code for allocating the object and initializing it, and does this in incredible speed, especially compared to what we've got on JRuby. So I was actually confused why this was so high. I thought something had to be wrong, like maybe it's not allocating the objects. So I fired up Mission Control, looked at a profile, and indeed it actually is allocating these objects that I'm creating. So it's just the fact that JVM can do this much more quickly and optimizes all of that Ruby code down to native. So let's look at an example of a more complicated object. This was additional difficulty for the JRuby optimization. Again, we see pretty much the same process. Again, a logarithmic scale here, about a 30% improvement again. A little bit more on this one because now we have an initialize that's written in Ruby. But again, JRuby, again, way up on top for that. So even with objects with their own custom initialize code, the Ruby code compiles to native. It inlines all the way back with all the allocation and is much faster. Now, we can actually throw some additional JIT compilers at this. I mentioned the Graal JIT has some advanced optimizations. Sometimes they work out well. Sometimes they're a little bit slower than Hotspot. But this is a fun one to throw at this benchmark because it's really good at getting rid of objects you don't actually use. So let's take a look at that. I'm not even going to include JRuby on this because the numbers get weird here. So there's JRuby 10 with 216 million. Kind of a spoiler here, I think. 216 million allocations. The Graal JIT can actually see all we're doing is allocating objects in a loop and throwing them away. And it basically eliminates almost all of that overhead. Now, if these objects had state, the state still gets used. The values inside my foo class would still be used. But if the object is thrown away, we don't actually need to allocate it. We just use what's inside. So these are the kinds of things that we get just taking the same Ruby code to a different JVM or a different JIT compiler. Now, this one I've been wanting to do this optimization for a while, and I thought, well, I'm flying to San Francisco. I'll do this on the plane. So respond to is commonly used for duck typing. Does it respond to this method? Okay, call it. Otherwise, fall back on some other logic, right? Commonly used for things like if it has a toStr. Is it too stringable? Okay, convert it into a string that way. Otherwise, do some other logic. And it turns out that this literal form is by far the most common for patterns just like this, where we want to know if it's duckable, duck typable as a stringable object. So currently in JRuby, we just compile this as a regular call to respond to, but respond to then goes and does a slow lookup to see if that method exists. Now that's not good enough. We can improve that. So here's the example I'm going to go through. Just call foo if the object responds to the foo method. Here's the previous workflow that we go through. So we've got our respond to foo in Ruby. That becomes an invoke of respond to with the argument foo. First, we check if we've cached the respond to method previously. If not, then we need to look up that method. We cache it in the call site. Then we can invoke it. And now we kind of got to do the same process again. We need to look up the foo method. Did we get something back? Is it implemented? Now we can return a result. But this part on on the left or on the right side here, we're going to end up doing that every time. There's no caching in the old JRuby 9.4 code of whether it saw the foo method. So what I did on the plane on the way here, I basically just used the same sort of caching logic, built it into our invocation logic in JRuby. So now it'll check, okay, did I cache respond to? All right, well, if it's the normal respond to, did I already look up foo? Have I cached the result of foo? I can just go straight to returning that result, skip this whole process, and as long as the type doesn't change, as long as the method table doesn't change, it basically boils away as a constant, and it's essentially free. And this took only a couple dozen lines of code in JRuby's compiler. So now all we're going to end up calling on a repeated invocation of this respond to is that stuff up at the top. So how does this work? JRuby 3.4 with YJIT. I would assume it's probably doing the same thing as JRuby 9.4. It can optimize the call to respond to, but then respond to has to go and do a lookup of the method on the current object. JRuby 10 still slightly better, but we're doing that same lookup. We're wasting effort. We're wasting time on it. With this optimization, though, easily a good 4 times faster here. This actually has some benchmark harness overhead. When I ran it as a simple loop, it was closer to 10 times faster. And it's essentially the same cost as just calling foo. There's no additional cost for doing the respond to at all. And these are the sort of patterns that they're just going to be little one-off things we can add to JRuby that really improve the performance of idiomatic Ruby code. Yeah, so there we go, about 4.2 times faster than JRuby and more like 5 times faster than JRuby with YJIT right now. Okay, so wrapping up here, talking about the future of where we're going with JRuby. So JRuby 10, we're really excited to be caught up on compatibility. We're watching the 3.5 features, and we're going to try and implement those alongside the work that's being done with namespaces and so on. But we're basically caught up. That means we can take a step back and do all of these cool optimizations like respond to that we haven't had time to work on for years. We spent all of our time trying to make sure compatibility is solid. So really, if you run something on JRuby and you find something that's slow, if it's slower than CRuby or just slower than you expect, let us know. We can profile it, we can find the right optimizations for it, and then the whole ecosystem benefits from it. I'm also super excited about all these JVM features that are coming along. The AOT cache is starting to really bear fruit and starting to get down half of what we could do previously for startup time. We've got a library in the JVM called Panama, Project Panama, that allows us to do native calls like FFI very fast as calling Java to Java. We're starting to integrate that into JRuby now as well. So FFI could be as fast as running standard Ruby or JVM code. And again, the JVM always is getting faster. All of the stuff we use continues to get optimized. So if JRuby isn't fast enough, it may only require you to get a newer JVM and you can get a performance improvement. And let's see. So as far as the development of JRuby, I mentioned that I've started a company, Hedius Enterprises, to fund JRuby support. And that process is going great. JRuby is continuing to move forward. We are offering support contracts for people that are interested in upgrading their existing JRuby, migrating to JRuby. If you've got some projects you want to test out, we're standing by to help prioritize your issues and be that virtual team member that can bring JRuby to your apps. It's really, we want it to be a partnership. We help your application run better on JRuby, and you can help the JRuby ecosystem grow and continue to move forward. I'm also happy to take support from individual users. I've got a number of GitHub sponsorships out there. I'm very thankful for that. We really can help just by trying JRuby out and let us know how it goes. If there's a library that's missing, tell us. If you're running something and it seems too slow, let us know. File bugs, try doing a PR. We accept pure Ruby implementations of missing features. Just jump right in. And you know, if you happen to be in the same place as me, buy me a beer. Save me a couple bucks. There's the QR code. There is information about the JRuby support offerings from Hedius and how to do sponsorship if you want to. And that's all I've got. Thank you. Now it looks like I think I left a room for a couple questions. Yes, in the back there. I can repeat it too. Yeah, go ahead and I'll repeat your question. Right, good question. So how does JRuby compare to Java for performance? On a benchmark like the red-black tree, where it's basically the same sort of object walking, just traversing a tree, doing some comparisons, very similar performance to what it would be if you were to write it in Java. The places where we suffer a little bit is because we use objects for all of our numeric types. The JVM doesn't optimize that as well. It has primitives that it can use. It can skip allocating the object. But there's work coming in a project called Project Valhalla that will solve that for us. We'll be able to pass objects and primitives with Ruby code and deal with that. I expect if we get that in place, which is slowly coming along, we can pretty much run any Ruby code as fast as any other JVM language, including Java. So it's for standard Ruby kinds of things, it should be pretty good. Numeric algorithms, faster than CRuby, but not quite as fast as Java.
The gist of how it works is I'm totally new to this. I first time hearing of JRuby was an hour ago. Do you hook into Java similar to like Node hooking into C, or I guess how does the overall in a nutshell work?
So the secret about Java and the JVM is that 98% of the JDK of the Java platform is just written in Java. And it all just compiles down to JVM bytecode and then does the exact same thing we do, just leans on the JVM's JIT compilers and garbage collectors to make everything fast. So we're essentially just like another compiler, a compiled language running on top of the JVM and taking advantage of all of the tooling and all of the optimizations that it does. Sure. Sure, go ahead.
So back in the day, we had a lot of monoliths. Now we have a lot of containers doing interesting things. And so is there an ecosystem of like containers with profiling built in and optimization that is happening in the Java world that now Ruby like can take advantage of in that environment? Thanks.
Yeah, so containerized stuff, pre-optimized profiled code. The AOT cache and the crack stuff would fit perfectly into that. If you want to have small containers that you can spin up quickly, you could checkpoint that process into your container and bring it up in memory. The AOT cache stuff, you could do that profiling and optimization and have your container start up with a smaller pre-optimized runtime. And if that's Ruby code that's JITted as well, it would take the same advantage there. We've actually been trying to improve our own JRuby Docker images so that it'll at least have the app CDS, the cache of class information, and possibly more, AOT cache, possibly a pre-checkpointed process, so that you can use the standard JRuby container and just get the benefit of that. There's also been a lot of work on shrinking the size of objects in the JVM, shrinking the overall memory footprint. And that's come a long way too. Like you actually can run some of this stuff in a much smaller couple 100 megabyte process with the JVM. I think I saw one in the back. I don't want to go too far over here, but.
Was there any particular feature of Ruby 3.4 that you found difficult, tedious, annoying to implement?
Oh, it's tough to say because we basically implemented Ruby 3.2, 3.3, and 3.4 at the same time. Difficult to implement? I don't think so. Fibers have always been a big challenge for us, and they're used more and more heavily. Well, thankfully, the JVM now has its own fiber implementation, so that's solved a lot of problems. I actually had a lot of fun implementing the data class, immutable struct. I used all of the latest tricks in the JVM so that when you declare a data object, it makes a perfectly right-sized JVM object, has an optimized path for allocating, and it's significantly faster than data in JRuby. But it was just fun to like do such a new feature and actually take advantage of all of the JRuby work we've done for years. I still need to go back and do the same thing for struct, but at least data I know is fully optimized. Nothing's really been too difficult. Fibers were the last thing that was really a challenge for us because there was no concept of that on the JVM. And I think we'll take other questions offline. I don't want to cut into the next talk too much, but I'll be here all night. See ya.
Thank you so much, Charles. That was awesome. I'm also a big fan of JRuby. Haven't gotten a chance to use it much recently, but at previous company, yeah, for sure. Thank you. Let's see. Okay, is Melvyn around? Melvyn from Clickhouse. Oh, I think he's over there talking to Irina. That's probably what's going on over there. Cool, cool. Yeah, you know what? I'm gonna literally Google the word jokes. Oh, I misspelled it. Okay. Okay, Pinterest? I don't think that's gonna be the right. Boy. Okay, a Reddit page. This could be good. Or it could be really bad. We'll see. No, that's not working. Here's some for kids. All right, Melvin's bailing me out, thank God. Yeah, no worries. So sorry, the Zoom link, yes. Yes. Perfect. You're good to go. I'll press that button first to get it to go green, and then yes, there you go. Perfect.
Hello? Test.
Okay. All right.
Okay, everybody. So today I'm going to talk to you about gem analytics, and I'm going to tell you about how we actually get that to work. So maybe a year ago or so, we started a project for analytics on top of ClickPipe. So I can show you what it looked like actually. So it was a project where we wanted to use our database. So I'm Melvyn. I'm working for a company called Clickhouse, where database. I don't know if anybody know Clickhouse in the room. There is a few people, and you know, at Clickhouse we have one scene, and it's we love data, and we we love collecting data, and we have a bunch of data sets. Sometimes we have like bird sighting data set, and we thought that analyzing packages for different language was fun. So we work with the Python community to actually create websites that use Clickhouse to analyze, you know, what's happening in the Python repository. So we created like this small project where we collected all the PyPy packages, all the logs, and we aggregate them into ClickHouse, and then we build some cool analytics displaying you things like the top repository, the emerging repositories, the repositories that are not updated anymore, etc. You can actually search for your favorite packages here. So for example, we can look at request. You can see that, you know, like how many stars it has, how many contributors, who are the top contributors for this specific project, the number of download over time. So, you know, like a bunch of analytics that can be entertaining for developers. And we put that together. And after a while, we actually started receiving an email from Ruby Central telling us, well, what you did with you know, PyPy packages was cool. Could you do the same thing with Ruby Central? So we say, well, of course, at Clickhouse we love data, and we can actually build something very cool like we did for PyPy. And some of the concept that we want to do is that because Clickhouse is very good at handling very large volume, we want to be able to be very granular into how we store the logs. So we don't want to do sampling, we don't want to do necessarily pre-aggregation, and we want to make sure that every single gems are actually represented in these downloads. We wanted to make it free to use, so we are using our hosted service, and we just like expose it directly via a specific application. And of course, because Clickhouse is a SQL-based database, we wanted to make it SQL-based, right? So you can run any type of SQL query, and then people can actually use it to explore some of the most downloaded gems out there. And of course, we also want to make it secure. And so we implemented on top of our service some type of throttling, and to avoid people to spam the services, or like you know, using all the resources of the cluster all the time by running like very expensive query. So we implemented some quota and restriction. So the main question is, when you do analytics, is how do you get the data? So and what question you want to answer. So typically we already had some experience with ClickPipe, with PyPy, and we knew that already a customer wanted to know, by analyzing the type of query that were sent to the repository, what type of query people will send to analyze gems packages. So typically, you know, like nothing very surprising. You know, what are the most downloaded gems? Which one are the ones that are emerging? The ones that are, you know, picking up steam? Download over time, download by system. Eventually, that help developer, you know, building their package properly, and so on. And then the second question is which data set to use. And so there is 3 data sets out there that we have been using. The first one is the download logs, right? So this is all downloads that are happening. It includes things like the package, the version, the platform, the OS, and some geolocalization data points. There is almost over 200 billion rows from 2017 to now. And every new month, it's 4 more billion rows. and this dataset is updated hourly, and it's very granular. And for us, this is kind of the perfect dataset because with Clickhouse, we can actually store all of that, and eventually we can also add some materialized view on top of that and do some pre-aggregation if needed. So the download log looked already perfect, but there was also two other datasets that we have out there. So the first one was daily aggregate download. So this is pre-aggregate dataset, and at the gem level, and it includes things like date, daily downloads, cumulative total. And the good thing is that it has a larger history as well, so you can go further back in time. And the latest dataset is a weekly data dumps. It includes metadata about each gem, each update that you are doing on the dataset, replace the old files in the dataset, and it's organized by folder to explore the dataset more easily. So now that we know the dataset, we know the questions that the user might be asking about. Let's see how we can actually load this data into Clickhouse. So to download the data, what we leverage GCS quite extensively. The dataset were compressed NDJSON, and the way we did it with Clickhouse is there is different ways to actually interact with Object Store. Clickhouse support many different functions, and there is two big functions that can be used. The first one is called S3Q type of function, and it's basically queues that can, and this is kind of what we illustrate on the illustration here. It's a queue that will monitor your object store, and it will monitor like every new file that is being added. And every time a new file is being added, we actually going to catch it, load it into Clickhouse, and keep track of the file that we just added to Clickhouse, so we don't reprocess it again. So that's one way of doing it, and we also, so that's very useful for new file, right? But then you have to do all the backfilling for all the previously inserted file. And for that, we used typically S3 clusters. So it's a function that you specify the object store that the bucket that you want to use. You specify a key, a secret. Eventually, you can also specify the compression format. And then you can specify additional settings like how many threads you want to use to read and to insert into Clickhouse. You can specify the size because Clickhouse process data per rows, right? So it's a bulk of rows directly for more efficiency. So you can specify, how big you want this bulk of rows to be. And then with Clickhouse, we're just going to backfill all this data. And we did the backfilling actually of the 180 million rows, I think in 20 minutes or something like this. So the other data sets were the weekly data dumps. And for the weekly data dumps, we used a very similar approach using a S3Q table, but we actually combined it with what we call a refreshable materialized view. So weekly data dumps were already aggregated data, and we can actually use Clickhouse to also generate aggregation. One way of doing aggregation with Clickhouse is to use refreshable materialized view. So it's a cron job that can execute a specific SQL queries, retrieve a bunch of rows, aggregate them in memory, and then output it into a specific table. So you can either replace a whole table or append the result set to an existing table. And we use these refreshable materialized views that are time-based. So here we actually do it weekly, where basically we're going to fetch some new data, aggregate them into, we don't necessarily need to aggregate them, but we can eventually if we want to, and then append it to the data set that we already have in Clickhouse. And materialized view actually in Clickhouse is a very powerful tool. We are using it almost all the time because it avoids doing very large data scan. And Clickhouse, compared to other systems, for example, like PostgreSQL, works slightly differently because materialized view in Clickhouse are insert trigger. So meaning every time you insert new data into Clickhouse, you pass a specific amount of rows, right? that are going to be inserted, right? So you insert, I don't know, maybe like 10,000, let's say 10,000 rows into your main table. And if you have attached materialized view to this table, Clickhouse is going to take this 10,000 rows and pass it along to the materialized view for aggregation. So every time you do a new insert, like it's going to trigger automatically the materialized view on this specific data block, right? So it's going to aggregate the data and then insert the output into a specific table. And it helps us a lot because using a materialized view, we can actually gain performance a lot. So let me show you an example here. This is the first query on the left is a query on a row table. The query on the right is a query that is doing exactly the same thing, but on top of aggregated data. And you can see the difference in terms of performance. We go from 5.2 seconds to 0.011 seconds. So for real-time analytics, it makes a big difference. So to query the data set, so we have a web UI that we created. I will show it to you in a bit. But we also, at Clickhouse, we love to use our own client. So we have Clickhouse client. You can use it to connect to the database. This is a command line that you can actually use. So there is a attached user with it, which is called demo, which has, like I will say the limitations that I mentioned previously. He's throttled in the number of queries per hours, the number of billions of rows it can actually read, etc. So you can use it to connect directly to the service and execute queries just in plain SQL. But let me show you the UI. So currently, we don't have like a dashboard like we did for PyPy. That's coming. That's some work we want to do to improve the project. But what we did is, this is, when I told you we love data sets, you can see I'm not lying. This is our demo environment, and we have like a bunch. We collect a bunch of data sets, and then we try to build like some queries for people to explore like this random data set that we found sometime, and that we have the right to use, of course. So let me try to find the right repository here. Oh, actually, I open it into another tab here. So yeah, so this is Ruby gem queries. There is already like a few existing queries that we put together. So for example, the daily count for gems. So you can actually run it, and you can actually see, how many gems were done already per day. You can see the emerging gems here. So we have like a few with an kind of nice bar charts in the background. You can see some of these gem. We, of course, this query are pre-built, so like we limit the number of rows we are showing to eat too much into our quota. But yeah, you get the idea. Like we have like a bunch of sample queries that query directly this data set that I've highlighted previously. Feel free to test it. You go to sql.clickhouse.com, and then you can find like this. If you go into the query tab, you can find like the Ruby gem one. Great. So I just did it. So yeah, so the cloud service that we are using behind the scene for this has 720 gigabytes of RAM and 180 cores. Again, as I said, we are going to build like a custom UI for it, similarly to what we did for PyPy. And we'll have, of course, more example of query. We will be able to have like drill down into specific gems and having a breakdown for each one of the gems that we are going to have. And we also want to have like reusable iframe widgets, so people can actually package that directly in whatever UI they want. And yeah, if you want to get involved, feel free to email the colleagues that put the demo together. He love contribution. And we also have like a longer blog article that kind of goes more into the detail of how we build this analytical platform, which is listed just right here. That's it. I don't know if you have any question.
I'm interested in your server architecture.
Uh-huh.
Do you have like a single machine running 720 gig or?
No, it's 3 servers. Typically, we are using our cloud. The default configuration is 3 server, and there is separation of compute and storage. So all of the data are actually stored in S3, and the compute server address here for query execution and to store metadata eventually.
Okay, cool. Very interesting.
So, correct me if I'm wrong, the question was, my data are in S3, did we consider putting that in memory and do... So, typically, like when we are using like the data volume is quite big, so fitting all of that in memory is could be challenging. Typically, Clickhouse has some data points in memory. So the way Clickhouse is built is that when you create a table, the first thing that you do is you need to create your order by key, and this is representing how we are going to store the data on disk. And the way we store data on disk, once we know it, we can create what we call primary index, and this index is basically sparse. So it's just a pointer to a specific, I will say, block of rows, right? So now that your data are stored on disk, you can create this index, and this index will just say like, okay, at the row 0, for example, you have that specific value. At the row 8,192, you have this specific value, and then you can actually do a search on this sparse index very efficiently, and you can reduce I will say the amount of data that you need to scan through very efficiently when a specific query leverages this index. So all this sparse index is actually loaded in memory in Clickhouse. There is also other caching mechanisms that we store in memory. So there's already like a few objects that we store in memory, but the data themselves, they are stored in S3. And eventually there is a caching layer at the compute node level where we can actually load parts of the data in SSD cache at the layer of the compute node. So each compute nodes come with a SSD cache attached to it, and we can leverage that as a disk and as a caching layer to speed up some queries that are querying, I don't know, hot data, for example, or things like that. Yeah. Any other questions?
Dashboard like the Python one?
Yeah, we will build a dashboard, definitely, yeah. It's coming soon. I will need to rerun some of these queries. I remember spending some time looking at it, but nothing out of the ordinary, I think. Just seeing the growth was interesting to see, like the number of downloads per day. Yeah. Maybe if there is interest in some other packages, we did Python, now we do Ruby. If there is some interest in other packages, we love to do this type of things. As I said, we love collecting data sets, so yeah.
Okay, when is Active Record driver for Clickhouse is coming out?
Sorry?
When is the driver for Active Record coming out for Clickhouse? That's what I'm interested in. You know, your integration with Rails. That's
Sorry?
what I'm. So Clickhouse
Yeah.
is a database. Most people here use Active Record as an ORM.
Okay.
And we don't have an official integration with Clickhouse. Yeah, there is one from. Yeah. Just pointing out. Yeah, you can you like lobby it inside the team?
Yeah, if you are interested, yeah, like we love contributors, so yeah.
No, I'm very serious.
All right, that is it for the first half of our program today. We will come back. Let's see, what time is it? Yeah, so we'll say 6:26, I guess, for open mic. If you'd like to speak during open mic, just form a line, probably up here by the chairs. And when we get started at 7:25, 26 or so, I'll just hand you the mic. You can talk for a minute or so about whatever you want to talk about, hopefully Ruby related. So with that, go mingle. There's still some food over there. And yeah, we'll see you back here in a few minutes. Ladies and gentlemen, please return to the main area for our open mic session. We will be getting started with open mic in just a few minutes. If you have something to talk about, please come line up to my right, stage right, I guess, your left, and we'll get this party started. Yes. Are you all in? Ladies and gentlemen, please make your way back to the main area. You can feel free to keep talking, but just do it more quietly. If you want to stay over there, that's also fine. You got this. All right. We're getting started in 30 seconds. 30 seconds. T minus 30 seconds and counting. Oh, yeah.
That's very quick.
See, Camille, I'm pasting the link to you as well. There we go. Are you on the Slack?
I am in the Slack.
Okay. Let me.
Well, I'm only on Slack on phone.
All right. Are you Brian Douglas?
Yes.
B. Dougie?
Yes.
Oh, you're already in this. Sorry.
Yeah, I already have. Yeah.
Okay. Are you gonna share?
Yeah.
There we go. Perfect. All right. Take it away. Sorry. Maria, right? Marissa, sorry.
Hello. So I created a Ruby gem, but I want to really just show if anyone uses Ruby on Rails. I actually been coding on there for a while now, and I didn't know that you could go in the console and put Rails notes, and it show all of your to-dos within your code. And recently on Ruby on Rails 8, you can now go on your local host and go /rails/info/notes and see all your to-dos. So hold on. Ooh, my ChatGPT. Yeah, if you type in Rails notes. And you could do this before Rails 8. And I didn't know that, and a bunch of my other friends who are also coding on Ruby on Rails also didn't know that. But it has like the default, this has the engineer's touch on it. So I created a gem that you can add to your project, and it just makes it a little prettier. Yeah, so. And you could, copy the links and then go to your repository and, check out the to-dos. And with this is only for the default notes path. It's only available on development. And you can add mine on production just in case you want to, you have an open source project and want to show your to-dos and notes. And here's like my other project with a bunch bunch more to-dos on it. But yeah, go. This is my gem and my repository. Give it a star or download it. And that's it. So thank you. How do I?
Stop share.
I don't need audio, right? I don't need audio, right?
I would probably share.
Will it work? Did it work? It is working. Okay. So, hello, my name is Kamil, and as you might have seen online, SFRuby is organizing a vibe coding hackathon. And yes. So Rails has been long known as the one-person framework, and we want to see how far we can take this with AI, LLMs, and so on. Ideally, we would want to see somebody code an entire app during one day without even touching a keyboard, but we don't know if it's possible and how far you can take this. But if anybody is able to do it, that would be fantastic. Here are the details. The date is Saturday, July 19th, so pretty soon, but there's still some time. The location is Sentry's office here in SF, and Teams is either solo or, through two people, 3 people, something like that, and there's no entry fee. We've got some updates that we can share. We've made progress. First, nearly 90 people signed up, so if you need social proof that this is happening, it is happening. There will be people, you will have somebody to network, have fun with, and so on, right? The second update, we have judges and mentors nearly confirmed. I think we'll start announcing them next week. We still need to do some work when it comes to that. Yes. Another thing is that we're working on the sponsors. And with sponsors, of course, come prizes. So if anybody is motivated by stuff like that, not just fun, then there will be prizes to win for the top teams. Obviously, we would highly appreciate anybody sharing the word about the hackathon. If you have like social media accounts, whatever, please share a link. This will be greatly appreciated by the team who's working on that. And if anybody wants to join, here's the QR code. You can scan it. It will point you to the Luma page that we usually use for SFRuby events. And feel free, as I said, to share, to join, and let's see each other at the hackathon. Thank you.
Oh, yeah. Sorry, new machine. Let me grab the super. So what do I got this machine on Monday? That's why I'm not prepared to Zoom. Cool. Hey, I'm B. Dougie, or Brian Douglas. Cool. I don't need audio. Share my desktop. There we go. Excellent. So I had a different. Perfect. All right. So vibe coding is cool. There's this website called amplify.dev, where we believe that developers should be amplified and not automated out of their jobs. Which I still think you should go to hackathon, but I've got some ideas and some thoughts. I actually gave this talk on Monday. This is not a talk. This is a demo, a really quick demo. I work at this company called Continue, and we sort of think about that sort of problem space. But what I've done is I was thinking through
12 years ago, I learned Ruby. It was like my first programming language full time. And I went to this like hackathon called the Global Day of Hack. And like Uncle Bob was there as well, which I didn't know who he was at the time. But I learned all about like test-driven development and like clean Ruby and all this other stuff by going to my local meetup out in Tampa, Florida, where I'm originally from. I live here now. So I had this idea where the game of life is what you learn there, and like test-driven development, spec-driven development. I wrote a spec on how to do the game of life. And what I've done is like I've got like a nice little prompt that essentially just takes my code base and that spec and then generates the game of life, implements it using test-driven development. So just sort of like showing this as a concept, trust me, it works. But I was thinking of actually submitting a talk to the SF Ruby conference and other places to encourage folks as you're thinking about like vibe coding or not vibe coding, why don't we just do what we did like back in the day? It's like tell the agent to write tests first, which it did. Actually, no, it didn't. It actually created my test helper file. But the next thing it'll do, it actually will create a test file. Sorry, it didn't. It created the actual. Oh, it created the class. Overzealous. You don't need to create the class yet. Just write the tests. And then what's cool about this, it actually will fail because there's nothing in that class as you just saw. It's going to run the test. I keep hitting the continue button because I work at a company called Continue, which we're kind of thinking about how we can support folks who don't want to use like foundational models like a Claude or a Cursor or a Copilot, but actually use the fine tune on your team. So you can build a bunch of assistants based on your monolith or your repo. So you might have like 20 assistants based on different corners of the code base. So happy to chat about that. We don't have a lot of time to talk after that, but here's my test. Trust me, it will run, it will pass. It'll probably have 2 failures and it'll keep doing the TDD thing as a cycle. So be Dougie on the world, and I would love to chat about this more.
Hello. My name is Miles Georgie. I've been a Ruby programmer since 2007. And for the past couple of years, I've been working on a software framework. And it came up, oh, sorry, I'll hold it closer. So the past couple of years, I've been working on a software framework. The gist of the framework is encapsulating high-level domain operations in commands, and then the framework automatically gives metadata about those commands so that it can be used to abstract away integration code. So you can focus on your domain logic and automatically get a command line tool or an HTTP API, whatever it is that you want. What sent me down this path is about a decade ago, I worked on a project with a really complicated business domain. And then just by sheer coincidence, the one I worked on after that had a very complicated domain, and then the one after that. And I started to notice similar problems on all of the projects. And so that, about a decade ago, I started doing the command-centric approach, and it really helped a lot. The problem there was that we spent a lot of time trying to get domain logic out of the rake files and out of the controller actions and keep them in the commands, and also keep stuff like HTTP stuff out of the commands. So it became like a big headache. But about 3 years ago, I was working on a project where we kind of experimented with this, with the idea of not writing controller actions or routes or anything like that, just completely abstract away the Rails router and all the actions. And it gave like a really good result. And it seemed like everyone on the team had a better understanding of the problem we were trying to solve, and development was was quicker, and the front end engineers were more focused on user experience, stuff like that. So that kind of gave me an epiphany and caused me to start trying to write a framework that I wish I always had for working on problems with complicated domains. So I was going to show a slide of it, but wasn't able to share my screen. But anyway, it's called Foobara, Foobara. And you can find out about it on at foobara.com or just searching GitHub or YouTube or whatever. Right. Thank you.
Howdy. My name is Sarah May. I don't have any slides. I am, here's what I'm interested in about AI. I am pretty much 100% uninterested in using AI to build new things. What I'm interested in the AI coding assistance for is in the code bases we all actually work in that are large and complicated and entwined and occasionally big balls of mud. And so I am going to be writing about that quite a bit if you're interested in that. I have a newsletter, and I also have cards with me today that have the newsletter on the back that you can sign up for. So if that interests you, please come find me and I will give you a card. The URL is sarahmay.substack.com. And that's spelled SARAHMEI. Thank you.
Thank you. Oh, we have one more.
We just happen to have Andre here. LangChain RB.
Thank you. I basically decided to do this like 5 minutes ago, so I just scribbled some notes together. Yeah, so my name is Andre Bondrev. Some of you have heard of this project called LangChain RB. Who here has used it before or tried it out? Okay, a couple of people. I wanted to kind of talk about some of the mistakes I've actually made with the project. I want to be humble when I say this, but I think I was pretty early at this to this intersection of Ruby and AI. I remember when the Ruby AI Discord group had just started, and it felt like there were like 5 or 10 of us kind of like driving some of these conversations. And there were not a lot of patterns or methodologies how to build AI applications. Not that there are too many patterns today. And certainly people were trying to figure out how does vector search work? How do embeddings work? How do these probabilistics machines even work? And so I got into the space because we just concluded a pretty big client project at the end of 2022, and I had sort of a lot of free time, and this ChatGPT explosion just happened, and I started really getting into vector search and trying to understand the capabilities there. Anyway, so in order to document some of my learnings, I created this LangChain RB library, and so there's a couple of mistakes I've made that I kind of want to sort of publicly recognize. I think the first mistake I made was not committing to deeper integration with Rails. So this was sort of before people start talking about this Rails renaissance again, and Irina is doing like a massive share of that, and I think it's completely justified. That Rails is going through its renaissance, right, and Ruby as well. But I created a gem as a Ruby gem, and of course, people are always like, "Well, what about background jobs? What about persistence? What about action view and all these components?" Another mistake I made is I sort of borrowed the name from LangChain, right? And I always say, while it was inspired by LangChain, we haven't necessarily tried to implement all the different things they do, which they do too many. And so some of this large optionality we brought into the gem, right? So like way too many vector search databases, way too many LLM providers, and there's no need for that. The docs have been kind of subpar. So borrowing the name of a library that nowadays kind of has a spotty reputation. You know, I sort of wish I would have been a little bit more responsive to everybody's like GitHub issues and concerns. Not putting strict guardrails on kind of the roadmap of the project. I didn't realize there were a lot of people actually rooting for the success of a project. And I just didn't know how to shape it right. This was my kind of first experience with a pretty popular open source library. But I think it led, it kind of kicked off this like evangelizing Ruby as a viable option for AI applications. And I absolutely think it is. And so some of the things I kind of learned in this experience is that when you're working on open source, you have to be customer obsessed. And your customers are other developers that are using your open source project. Just like customers that are paying you money. In this case, the customers are not paying you money, but you have to be just as obsessed with delivering value to them. You have to be really nice to people. You have to be responsive. Dev has a very high churn. You only get one shot to basically solve somebody's problem as they're playing around with the tool locally. And if they have a good experience, they're probably not going to come back. And it's extremely difficult. I have massive respect for all of these decade-old open source projects that we all use, you know, Devise, Sidekick, all these other tools that we just take for granted. We don't even think about like how many sleepless nights and went into building some of those tools. And they're all free. Well, caveat there, but you know what I mean. So, you know, what's next? Some things I've been thinking is like, we got to ditch the LangChain name. It makes no sense. We got to rebrand. We got to build deeper integration into Rails. Like, again, I know there's people trying to expand Ruby's usage beyond just Rails, but you know, Rails is sort of like its massive success child. So, another thing I wish that I could kind of figure out is like how to bring people together, organize them to have a very productive open source sort of team of core contributors and maintainers. So, yeah, thank you.
Awesome, thank you. All right, our next talk is from Mr. Kieran Klaassen, I believe. Yes. Is that how you pronounce it? Okay, perfect.
Kieran, are you gonna be quiet? Because I'm gonna put the volume up. Okay. Yeah.
Hello.
Thank you. Okay, I'm going to talk about AI stuff. The thing I love most is Ruby and AI. So and I'm here with Ruby AI friends. So thank you for inviting me. Um, it's really fun. Okay, let's start. Who here has shipped AI apps like using Ruby? Okay, how many of you have actually evaluated the things you shipped? Okay, well, it's not too bad. So I'm Kieran. I use AI or like use GPT-3 since the beta 3 years ago. I'm a big agentophile, which I titled myself, which means I like to run multiple agents at the same time. And I build multiple AI-powered companies and use AI also to build them. Currently, I'm building Cora.computer, and we're connecting to your Gmail inbox. We clean it up, and we only show the most important things. I'm an entrepreneur in residence at Every, which is a media company in New York. We're writing about what's next in AI, which is really cool because I get access to all the models before everyone else. So I vibe check Claude. I don't know what it is, but it's something, and then it turns out to be 4 or like whatever. It's really fun to do. I hope to be inspiring the Rails community to build with and for AI. And I have a few libraries that I put out there. I've never really promoted them, but I know Andre looked at some, and Justin and I talking, and like it's just fun to everyone talking together, seeing, shaping, and seeing what it's going to be. So I make music, bake croissants, other nerdy stuff. But why I never did evaluations was not ignorance. Mostly it was friction. And it's just hard to export data to Python. It's too much work. External services, you need to sign up. You need to set everything up. Manual testing doesn't really scale. So before I built Cora, I was just winging it. Just go with the flow. And pain points I was expecting building Cora were these. It works with 5 examples, but once real data hit, suddenly real user data is giving way different outputs. This can be because there are many tokens or the context is not correct or like whatever it is. I couldn't really use external tools because I dealt with highly private, sensitive information, all encrypted. So that was just a technical barrier I couldn't really do. Model management, what if a new model gets released? Is it better? Is it worse? No idea. Cost surprises when you scale up, different shapes of data, models getting deprecated and you have to migrate to a newer version. Is it the same? Is it different? No idea. Debugging hell. Is it the prompt? Is it the context, the model, the Rails code? Could be all of it. So there's no stack trace for AI failure, really. Like it's great if you get an error in your debugger and say, oh, it's this line, this number, that's it. AI doesn't work really like that. People saying it used to work better, and you agree that it used to work better, but why? Silent failures in production. AI evaluation tools don't really fit the Rails patterns. And one of the biggest things is if you have human feedback in your database, it's really hard to get a pipeline set up to put that back in and start training or fine-tuning or evaluating with that data. And that's very important. So my goal today is to show you evaluation-driven AI development the Rails way. And it's kind of TDD for Rails code, but then EDD for AI features, so evaluation-driven development. So we saw TDD in action, works great with AI. Well, EDD works great too. This is how I look at it a little bit. You have traditional tests to your code, and you have evaluations to your AI prompts. And also you have stack traces to your code and a chain of thought to your AI prompts. So I started building Cora and I started searching for, and there has to be something, maybe Andrew Kane did it 2 weeks ago. someone needed to have done this. But no, there was nothing. But I was thinking it wasn't actually that complicated. I've been using LangChain for like all the years before because that was what people used, the Python version. And so I used that for evaluation. And I was like, yeah, it's not that hard. So let's build something myself. So introducing Leva, the Rails way to evaluate AI. It's linking to Active Record. It's a mountable engine with a UI, so you can work with it in a visual way in production. It works with encrypted data on production because it's in your Rails app. It has Rails generators, and it's built by a single developer building a company for other single or maybe a little bit bigger Rails devs. So classifier, how does it work? This is the demo. You add the gem, you install the migrations, you migrate, you get 3 models, you include a concern in your active record model. The next step is a runner, and the concept of a runner is this executes your LLM call. It could be anything. You can do no LLM call here, but it's for LLM, so please. Here I use Ruby LLM, but you can use any library, you can use your own client, doesn't really matter. You can make it as complex as you want or not. And you have a record here, and that record can inject the grounding context for your prompt. And you have access to a prompt here that you get from Leva as well, that you can use for iteration from the UI. The next one is the eval. You can add as many evals as you want to runner, but we'll do one, which is it accurate, yes or no? And this is just Ruby, however you want to do it, as complex or not. The next step is gathering data. So here I made a beautiful hand label script. I just add a bunch of records to a data set. And I start with my baseline prompt. This prompt can be done through the UI, but you can also do it like this. In the end, probably you won't use this system to run your prompts, but this system is used to experiment on your prompts, and you can then store it to wherever you store your prompts. You run it, you see 30% accuracy, and you go to the art of the prompt engineering, where you jump into the UI, for example. You go to the workbench, you pick a result that is failing, and you look at the role prediction. So I like to enter like a chain of thought in here, so you can actually understand why it is going that way. And you can start experimenting with your prompt and running it and running it and running it until it's actually outputting what you want. And that is what you did. You updated your prompt, and now it's 91% on your whole data set. Well, obviously it's harder, but that's the loop you go through. So art and science in harmony. We need them both. Demo 2. This is a real one. We were running categorization on Claude Haiku 3.5. Worked great, but it was expensive. We were paying hundreds of dollars per day. So when Google Flash 2 came out, I was like, ooh, 10 times cheaper. How bad can it be? Before you would just do, let's see what happens. I did it, and it was 8% worse, but I saved $100,000. So it took me 10 minutes to do this, which was really nice because I had my data set already and I could use that data set at any point. I have a question. Yeah, but you have, yeah. Okay, so he said 2.5 is better, yes, but it's also more expensive. And also this was months ago. And also there's a token limit. So I use too many tokens to run 2.5, even with unlimited tokens from Google, because it's in preview. Yes, and it's better. But I still use 2.0 for certain things because it's still 10 cents cheaper. Human feedback. So Cora archives your emails if it thinks you don't need to look at it right away and briefs it. Sometimes we mistakenly archive an email and people return it to the inbox. So we have just a human feedback loop where we say, hey, miscategorized, we push these to a data set of failures, analyze the chain of thought. So we store the initial chain of thought for the categorization, so we can analyze where it went wrong and then change the initial prompt. And we can then run the eval on that data set. I'm going fast, but we are running behind a little bit. So remembering, I think last talk was like prompt engineering is art, which yes, it's art, but we also need evaluation for science. We need both, because otherwise it's just going running wild. And you can do it in different ways. You can have an evaluation framework, or you can have a pipeline. Like there are different ways to constrain the LLM to do the right thing. I like evals because you can let the AI do the powerful thing and steer it in a controlled way like that. What I'm building right now, like this is basic stuff, but what I'm building now and very excited about is having Liva providing data, having like a bunch of agents analyze the chain of thought and improve the prompts, and then automatically rewrite the prompt and then have Liva validate it again and loop that. It's just TDD, automated, using AI, but then for prompts. It's like a light step for fine-tuning if you don't need to go full on fine-tuning. This is a very good first step. And the beauty is, like, I can do this for the prompt, but if you need to generalize. If you have thousands of users, you can run thousands of customized prompts automated like this. So this is happening on Cora production right now. If you're interested in any of this, talk with me. I'm on Twitter, GitHub, email me. And if you want to try out Cora, this QR will give you access because we have a wait list. So feel free to try. Okay, there's a guy smiling very, very much there. Yes. Can you run Liva and CI? Yes. I don't run it in CI because I want to do an experiment. So I want to have like a hypothesis of like, I think this thing is going to push the needle a certain way. So it's less about regression. It's really like I want to test these things when I do changes. That's the most interesting. But you could totally run it, and like if a model degrades or if you upgrade that, it will catch it for sure. Am I familiar with the scientist gem from GitHub? No, I'm not familiar. Was this out a year ago? Because I needed it a year ago. Okay, well, is there a UI to it? Okay. Yeah, so I just build it. I need a UI because in production, if I see something that is wrong, I want to click a button and immediately go to my prompt and fix it. I want no friction. I don't want data science stuff. I just want something that works for me as a single developer, which is this. That's why I created it. But yeah, I will check it out. I want to be inspired by everything. Yeah, thank you. So every time, the question is how consistent are results if you run the same experiment on the same data set? If the data set is pretty big, like hundreds, thousand, it's pretty consistent on like the points. But if it's smaller, it's less consistent. It also depends how hard it is. Like, are you doing yeah, it's pretty consistent. What are my strategies for dataset collection? So manually labeling, human feedback those are the biggest ones. Do I do any smart caching? No, no, I don't. I'm a single dev, and right now that's an optimization. I rather pay 10 cents more than thinking about caching and everything like that. So, but yeah, like totally. Like this is just a tool for me that I needed to move faster, and I wish existed, and it didn't exist. And yeah, there are a million things I could do that could go into this for sure. Thank you.
Thank you, Kieran. Ooh, that's way louder. Nice. All right, our last talk of the evening is Dr. Justin Bowen.
I am not a doctor, also not a scientist. Let me share my screen. But I'll take the title if anyone wants to give me a PhD. I'm in the Zoom. Oh no, Irina sent an email. She's on top of things. You guys are both on top of things. All right. So today, I'm Justin Bowen. I'm always Justin Bowen, but today I'm Justin Bowen talking about active agents again, but also going to do a bit of a live demo. So yeah, let's get started. When we talk about web application development, we talk about MVC, and that's something that I've been trying to figure out is how does AI development fit into our Rails application in this common pattern? And what I've come up with is prompt contexts are that data model, the agents are the controllers, and action prompts are the views that can render content or UI. Now, to take a step back, I brought up this at the SF Ruby, and this is a concept that has been around for like 30 years called agent-oriented programming. And you can just think of it as like object-oriented programming is lifeless objects that we give attributes to that have methods that we can call, where agent-oriented programming are classes that have a persona with instructions and an intent that can perform actions. So all of those things. And so this I actually took from the Rails guides, I think, and just slapped on my logo and changed a few things. But agents are the controllers, and that's what we'll get into in the code, where you define an agent class. All of your public methods become actions. Those actions can be tools that the agent can call, or you can invoke them directly. So common patterns that everyone has probably experienced or tried to implement at this point are interactive conversations or autonomous operational agents. And so we'll do both today, and it should work. So yeah, like conversational agents, I've seen a lot of things that are basically like long form data entry wizards where honestly the interface for a form is probably more efficient than a conversational interface, but they're cool and everyone wants AI chatbots, so we do it. And yeah, they can interact with third parties through tool calls or MCP. And then autonomous agents can perform operations like embedding, composition, moderation, and the last thing I added, which is all the way at the bottom for a reason, is translation, because I did that earlier during Charles's presentation on JRuby. I didn't do it in JRuby, but there will be cats. This is my cat. She's 17 years old, and I actually found out recently, like maybe a year ago, through an icebreaker at a company I was working for as a staff AI engineer. I use air quotes because we're all AI engineers now because we all make web requests. But I found out that my first Amazon purchase was actually Obi Fernandez's The Rails Way in 2007, which is about the time I got Lehui, my cat, in this picture. And so, like I said, this will be cat-themed to start. And then maybe a little translations if it works. So let's go to the browser. And we can just say hi. And we can ask, what can you do? And see what it says. Okay, it says it can show us cat images. How can it show us cat images? Well, in our agent class that we were talking about earlier, this should look very familiar if you've ever worked with Action Mailer or Action Controller. Who's used a controller before? Cool. All right. So you're familiar with callbacks like before action or after action. That's supported. There are also before generation, after generation, and on stream that allows you to perform something every time you get a new chunk in. And so that's what you were just seeing responding to the messages. But of course, we want to see a cat. So let's look at the cat image service. I forgot to bring that up. But all it does is it goes to catasaservice.com/cat. And just to prove that this is a real thing, it's a real thing. That's a cat. Okay. So now, show me a cat. I didn't need Cameron to hold the mic, actually. No, I did not. I just realized it. And we should see a cat. Well, let's see if it shows us a cat. I don't know. Is there a cat? Let's check Sidekick. Were there errors? No errors. We're doing it live. I swear it just worked while I was sitting down. You saw a cat. Daniel, did you see a cat? He saw a cat. Cameron, am I going to have you hold this? Let's, you know. Okay, we'll come back to the cats. I promise we'll show cats. But I did put together a translation agent that we'll also look at, and I swear it just worked. You can see it like right here. See? That's French. I don't speak French. But let's do Japanese, because I have Japanese on my shirt. We were just at Ruby Kaigi with our friends Charles and Jeremy. And yeah, Japanese. And this is an example of calling this action directly. So we're going to call translate and generate now. And then we're just going to see what the content of the message is. And it's Japanese. I don't speak Japanese. I assume that says, hi, I'm Justin. Watashi wa Justin. Maybe. And yes, yes, I assume konnichiwa. All right, let's just restart the server using Overmind. And also, let's just clear that chat. Okay. Yeah, let's just get right to it. Let's just see if it shows us a cat first. Cat. Okay. So cats and translations. Let's actually take one, and then I'll just wrap up because I know we're behind. Neko-chan. So this is actually the interface for the controller that is using the support agent that shows cats. That's the only function that the support agent can do, because who wouldn't want to see a cat when they need support? And you can see it's very similar to how you might call a mailer in a controller. and you use generate later. And this will trigger a background job in Sidekick again. I don't know what happened. We're doing it live. This is running on my laptop. Maybe it was just a bad web request. I don't know. But yeah, very simple controller passing in the message from the content that we typed in. The chat ID is the context ID that gets passed to the support agent. And then the content type is an image URL. And we just throw in that base64 image and ChatGPT accepts it. And let's see if it describes the cat. Maybe. And yeah, I broke the auto scroll earlier. Don't judge me. Ah, it's cute, small, feline, fluffy coat. This is from 4.1 Nano, so it's kind of a generic description of the cat. But that is that. Oh, also, Andre, I really resonate with the whole better docs thing. So I have better docs that I've been working on since we were in Japan, and they're not deployed yet. This is also on my local machine, but they will be coming soon. They have examples of how to do stuff. What's an agent? What's a prompt? What are messages? Instructions is message. Again, action view for rendering prompt templates and views to the users. That'll be coming out maybe tomorrow if we're lucky, maybe next week. By next week at least, I said on the podcast this morning. And thanks to Clickhouse, we can see a chart of active agents, gem downloads, and oh wait, maybe it's too small. Lots of downloads in March, but let's see some more downloads down the line if you want. Go to activeagents.ai or go to not GitHub's organization, but Active Agents. And yeah, star the gem. I definitely just starred Kieran's gem and also tried to find the pretty to-dos note gem to star, but that's like the lowest effort thing you can do to support open source developers that you don't pay. But yeah, I think, what else can I do right now? Oh, yeah, thank you. Well, before that, why do this? Because Ruby needs better AI tooling. It's something I've talked about a lot, something I'm hoping to work with Ruby Central on. There's a QR code. If you're interested in working with me, I do contract work. Also, if you're interested in contributing, that's another thing I resonate with Andre on. It's hard to contribute sometimes. Join the Discord, just chat. Yeah, thank you. Also, be sure to sign up for the SF Ruby AI Hackathon, vibe coding hackathon. Yeah. And hand it. Oh, wait, questions? I don't know. Do we have time for questions? I don't know. I'm just saying go to the hackathon. Any other questions? Rhiannon. That feels like a loaded question. Why is agent-oriented programming the best way to build AI in Rails? What's that? She did prompt me. She prompted me very well. You know, it's interesting. I think the term agents has been overloaded, and a lot of people just think about code generation, vibe coding, but I really don't think that's where the value is. I think having these, again, intelligent objects that can perform actions on their own is this new paradigm in programming that we've been hoping to have. It's like what we used to think computers in the future might be able to do, is like some kind of thinking and reasoning on their own. And with Active Agent, you can do that in a fairly recognizable and familiar fashion as a controller. And yeah, I think AI is not going to replace developers anytime soon. I use AI agents a bit for development ideas, but it's awful for generating code. It doesn't understand anything, especially when you're doing new stuff like active agents, even though this is based on like a lot of stuff from Rails internals. It doesn't really understand Rails internals either. Maybe Rails Foundation and Ruby Central are working with people on that, but yeah, question. Yeah, no, that's a great question, but I don't know if we have time for questions. What? Oh, I thought you were saying hurry up and like shut it down. How do you control costs? I think that's another thing that I'm looking to do in the future, potentially as a paid service, is evaluations, cost monitoring agents in production. There might be some open source tooling around that as well. Yeah, like a lot of the best practices and techniques that you use for background jobs, like retry logic, can be used to make sure your agents don't just run out of control and like rack up costs like in a cycle of confusion. Because again, you know, they're not the best. I've worked with AI for a decade, but I am very skeptical on the whole AI hype cycle. Someone said Web3 earlier, and it was very triggering, but it does remind me of this AI hype cycle. Thank you, Matt. Any other questions? Did I answer your question? No? That's okay. Nelson? Is this your ICO? Yeah, no, that's trigger word for sure. All right. No more questions. Yeah, are we going to Terminus after this? I don't know. Brandon's usually the one who announces that. But Charles, maybe I'll buy you a beer. I saw it on your slide. Yeah? All right. Here, Irina. Please take the microphone.
Okay, you know, folks, Ruby engineers always told me that AI is so much better at generating JavaScript. You know why? You can guess. I think it's the same effect as, you know, when you're reading the news on the topic that you're not familiar with, you think the author is so good. We got stickers. We have a whole range of different selection of stickers. So we're wrapping up. I thank you all. When are we going to be kicked out of here? 9? 9 o'clock. Okay. So at 9, we're going to head to the Terminus. It's right here, the bar that is very close. Terminus, am I saying it right? Yep. Like last few times we went there. Yeah, follow the guy in a Ruby t-shirt. And yeah, again, thank you all. Let's hang out for a bit and then we'll see you in the bar. Thank you.